Welcome to math class! Today we are going to start adding and subtracting fractions. The past few days we've been comparing fractions, trying to make them have the same denominator by multiplying them by something or dividing them by something. All right, so today when we go to add them, we got to follow some specific rules. Because if I add a half plus a sixth, I get 2/3. So adding fractions, it's not just add the tops, add the bottoms, because then I never end up getting 2/3. Okay? We need to split them up so they all have the same denominator before I can add them. Okay? Because this is 1/2, but if I want to add it to 1/6, I want to turn my half into sixths. Okay? 1/2 is really 3/6. Okay, we grew it up to have the same denominator. Okay, 1/6 is still 1/6. So now I can add these. 3/6 plus 1/6 equals 4/6. Okay, 4/6 reduces to 2/3. Okay, so that's how we end up getting something like this. Right? So when we go to add these, we have to get them all to have the same denominator. Okay, I see all of these numbers can become a 6. Okay, 2 becomes a 6 if I multiply the top and bottom by 3. So 1/2 became the 3/6. Plus the 1/6 that we already had, and then 2/3, if I times it by 2, becomes 4/6. Okay, this one makes sense. Right? So now the rules that I'm going to follow, we're going to add the tops, but the bottoms stay the same. Right? We're going to add the tops together and keep the denominators the same if they already have the same denominator. If the bottoms don't match, we have to get them to be the same thing like we did yesterday. Okay? So for the first several, these ones I can already solve. 1/18 plus 11/18 is 12/18. Okay? When we do these though, we'll probably want to reduce them if we can. So 12/18, if you put it in your calculator, alpha y equals, it'll reduce it for you. Let me pull up my calculator. Calculator, here we go. Okay. So if I go to 12, or let me alpha y equals that. Alpha y equals 12 divided by 18. Right. My calculator will already reduce it for me into 2/3. So here 12/18 can reduce to 2/3. Right? I could divide them both by 6 to get it down to here. Alright, these ones, add the tops, keep the bottoms the same. Can 5/7 reduce? No, so we could leave it like that. 5/12 plus 3/12, add the tops, keep the bottoms the same, I get 8/12. Right? That can reduce. You could either put it in your calculator to see, or think of a number that you could divide both of them by. It'll become 2/3 if you divide them by 4s. And the last one, 1/9 plus 8/9 equals 9/9. 9 divided by 9 is 1 if you reduce it. Okay? So we're always going to try to reduce if we can. If you have trouble with that though, we can use the calculator strategy. Type it in alpha y equals, it'll automatically change it into the reduced fraction for you. Right? So now with these ones on the bottom, I cannot add them until their denominators match. Okay, so we're going to use the strategy that we did yesterday. I'm going to try and turn the 2 into a 24. Okay, how does 2 turn into 24? I have to multiply it by 12. So 2 times 12 is 24. So what's 1 times 12? It's going to be 12. So if I go to add these, 12 over 24 plus 12 over 24, add the tops but keep the bottoms the same, I get 24 over 24, which reduces to 1. Okay, so we want to get our denominators to be the same. If you want to use the multiplying trick like we did yesterday, if you don't know what 7 and 28 become together, if you don't know if 7 goes into 28, I can multiply both of them. 7 times 28 is 196. So I can turn both of them into 196. Okay, 7 times 28 gives me 196. 28 times 7 gives me 196. Okay, I'm going to need my calculator for some of these. 3 times 28, 3 times 28 gives me a numerator of 84. 3 times 28 gives me 84. 9 times 7 gives me 63. If I add these together, 84 plus 63 is 147. Let me double check the mental math there. 84 plus 63. Yeah, 147. So now I have this fraction, 147 over 196. That's gross. I want to see if I can reduce it at all. So if I go to my calculator, since that's a big number, alpha y equals 147 over 196. It reduces to 3/4. Okay, a much nicer fraction. All right, so when we do these, we'll try to see if they do reduce. All right. So we can try this one, but I'm going to skip it just to get to the next one because there's more room over here. I know 9 can become 63. So this 9 I know can become a 63 if I times it by 7. Okay, so if I times my 1 by 7, I get 7 here. Now that the denominators are the same, I can add the tops and keep the bottoms the same. 7 plus 49 is 56 over 63. Okay, I'm going to see if it reduces. Alpha y equals 56 divided by, whoops, I don't need the divide, I could just put it in the bottom. 63. It ends up being 8 over 9, 8/9. Okay, so for these ones, we're converting them to have the same bottoms, and then we're adding the tops together, keeping the bottoms the same. On the flip side, we're going to do the same rules, but with subtraction. Okay, so we'll get the denominators to match, and then we'll just subtract the two. Now for some of these, if you have a whole number, don't worry. Remember, you can write a whole number as itself over 1. So 3 can become 3 over 1. Right? If I want to subtract these, I need a common denominator. Let me get both of them to become 24. Okay, 12 over 24 is already good. To get 1 to become a 24, I have to multiply it by 24. 1 times 24 is 24. 3 times 24 is 72. If I subtract these, I get 60 over 24. Okay, I'll see if it can reduce. Go to my calculator. If you want, this might be a nice decimal. If I do 60 divided by 24, it's about 2.5. Or if you do alpha y equals 60 over 24, the fraction is 5/2. Okay, so if it's a nice decimal, you could write it as a nice decimal like 2.5. But if you get 2.333333, I think it would be better to write it as a fraction. Right? For some of these, we can get the same denominator. I know I could turn a 7 into a 28. I just have to times it by 4. So 7 times 4 is 28. 3 times 4 is 12. I could subtract these now. 12 minus 8 is 4. Keep the bottoms the same. 4 over 28. If you go to reduce this in the calculator, you'll get 1/7. Okay? So subtracting and adding are all the same. You need the same denominators to be able to add the tops or subtract the tops. So I'll do one more. This one, I've got two that don't grow into each other. 9 cannot become 10 through multiplication without a decimal. So I'm going to try and change both bottoms. Okay, 9 times 10 is 90. So let's get them both to have 90. Right? To turn the 9 into a 90, I got to times it by 10. 9 times 10 is the 90. What's 4 times 10? Because whatever you do to the bottom, you got to do to the top. 4 times 10 is 40. Okay, on the other side, I've got 10 times 9 is 90. So what's 7 times 9? That's 63. Right? When I go to subtract these, can you do 40 minus 63? You can, you just get a negative number. Okay, we're going to get negative 23 over 90. That does not reduce. I could leave my answer just like that. Right? So when you're adding or subtracting fractions, change the denominators to be the same, and then add your tops, keep the bottoms the same, or subtract your tops, keep the bottoms the same. All right? Good luck with the homework.